The ferrocement, the bottom reinforcement cage with 8 mm diameter steel bars, skeletal reinforcement, and 4 mm diameter transverse reinforcement, along with the stirrups, and the 3 layers of chicken mesh were placed. The reinforcement cage was placed over the cement mortar spread inside the mold. And here you can see the openings in the sides of the mold. The PVC pipes were inserted through the openings made in the mold to make the hollows, and cement mortar was spread to form the ribs. Since the mold was kept over the vibrating table, a few seconds of vibration were given for compaction. And the reinforcement cage, the top reinforcement cage was placed over, and the stirrups were hooked over the skeletal steel on top. And another layer of cement mortar was spread, and it was finished smooth. Efficient compaction was achieved by vibration over the table vibrator. And after a day, the mold was removed, and the slabs were cured under complete immersion condition in tanks. The slabs were cured for a period of over 28 days, and after that, they were taken for testing. So the slabs were tested on a loading frame. This is the experimental setup. So the load cell was there to record the loads, and LVDTs were kept to measure the deflections. And this is a curvature meter fabricated to measure the strains, and a data logger was used to measure the record the load and the deflections. So 2 different loading patterns were followed: monotonic loading and cyclic loading. So under cyclic loading, these are the 2 different loading sequence adopted. So the loads were gradually increased till ultimate, and the second loading sequence at close to the ultimate, the number of cycles were repeated, and then it was taken to the ultimate load. And to study the influence of the polyester fibers and enhancing the flexural strength of the ferrocement hollow slab, these low deflection behavior, moment curvature behavior, stiffness, ductility, energy absorption capacity, crack width, and toughness were studied. Then this is the low deflection behavior for monotonic loading. So these 2 curves indicate for slab without fiber, and these 2 for ferrocement slabs with fiber. And there was average increase in first crack load in case of slabs with fiber. The average increase in first crack load was 12.5%, and the average increase in ultimate load was 28%. So these are the first crack load readings and the deflection readings observed in these slabs without fiber and slabs with fiber. And this is the low deflection behavior for cyclic loading. So all these are for cyclic loading sequence 1, and this is for cyclic loading sequence 2. So in cyclic loading sequence 2, we can observe that the cycles were repeated at loads closer to the ultimate load. So this is for without fiber, and this is for with fiber. So on comparison, we saw that slabs with fiber had a higher load carrying capacity, and the ductility was more in the loading sequence 1 and in loading sequence 2. So these are the first crack loads observed and the deflections observed. These are the ultimate loads. So here in this, from this, it was concluded that the addition of polyester fibers enhance the first crack strength by 9% to 10% under cyclic loading. And the ultimate load carrying capacity of hybrid ferrocement slab was found to be 26% more than that of the slab even without fiber. And slab F3 with fiber showed 22% higher load carrying capacity than slab E3, which is due to the bridging force offered by the fibers embedded in the mortar. So this is a moment curvature behavior for monotonic loading. So here the average increase in curvature at ultimate moment was 16.75%. And this is the moment curvature behavior for cyclic loading. So here also we have the readings: first crack moment, curvature, then ultimate moment, and curvature at failure of chicken mesh. So this is the flexural rigidity curves. So the stiffness, this indicates the decline in stiffness as the moment increases. So here the for the fiber enriched slabs, the stiffness was higher when compared to slabs without fiber. And the ductility is a very important factor to be studied, so that we can so the average increase in deflection ductility under monotonic loading due to addition of polyester fiber is 12%. So here this is a deflection at yield and this is a deflection at ultimate. So here the deflection ductility is calculated by dividing deflection at ultimate by the deflection at yield. So these are the ductility factor for monotonic loading, and this is for curvature ductility. These are the values for curvature ductility. For slabs with fiber, the curvature ductility increased by 14%. So this is for cyclic loading. So for load cycles, for every load cycle, the deflection ductility factor was taken and a graph was plotted. And here the blue indicates without fiber, and this pink one is for with fiber. And here it is seen that the increase in deflection ductility varies from 14 to 16%, and the increase in curvature ductility varies from 17 to 18% for ferrocement hollow slab subjected to cyclic loading. So this shows that the fibers delay the snapping of wire meshes due to their ductile nature. And energy absorption capacity was also found, and it was the average increase in energy absorption capacity is 2.12 times that of capacity of hybrid slabs without fiber. So here we observe that the cumulative energy absorption capacity was more for slabs with fiber when compared to the slabs without fiber. So this is the cracks formed on the tension phase of the slab. Actually, the slab is kept. This is the tension phase of the slab. We can see numerous cracks on the tension phase, but the crack width was less. So under monotonic loading, the number of the load at which crack width of 0.1 mm occurred was 45.5 kilonewton for slabs without fiber and 56 kilonewton for slabs with fiber. So this graph indicates the load and crack width, the crack width which occurred at various loadings. So this is for cyclic loading. So everywhere we see that the crack width is less in general for ferrocement hollow slabs. And when fibers were used, the crack width still reduces. And toughness index was also calculated, and it was found to be higher for slabs with fiber. So all these points I've already told in my lecture. Thank you. So now we can have a discussion.
Yes, thank you, Dr. Rajkumar. It was a very unique kind of experiment, the kind of research you have done for showing the behavior of the hybrid structures. By hybrid, you just explained. I will having just a small query. It's a mixture of chicken mesh and polyfibers, right?
Yes, sir. Yes, sir.
Many researches and experiments have been also done in MIT Pune by Dr. Kulkarni and many her colleagues.
Okay, sir.
They have not used the chicken meshes at all. Only the welded meshes and sometimes fibers and without fibers. This kind of experimentation they are doing. There might be some other experts' experiences. But my question before is, in some episodes earlier, there was a question of chicken meshes, roll of chicken meshes in ferrocement for the discussion. So I just ask a basic question. Maybe Dr. Kulkarni will tell her opinion first, and then you can answer along with the query.
Okay.
So the question is, can we really define the exact role of the chicken meshes in ferrocement component, and for the design purpose, whether it can be totally eliminated? If added, what are the advantages?
No, in fact, I was very much impressed. I must first congratulate Dr. Shoba ma'am for a great thesis work, because it almost includes everything that we are asking for, trying to prove what ferrocement is. Almost everything, because she has come to the first crack, she has come to the crack widths, she has shown the crack widths are large in number but small in crack width. But I'll come to sir's question immediately, and then later on I can say something on that. Basically, there is no confusion or there is no issue about using chicken mesh at all. Why chicken mesh was not being used was because generally chicken mesh comes in rolls and it has to be pre-stressed. Now the word pre-stressed might make us a little uncomfortable, but what it means in ferrocement, pre-stress is very simple. You have to just stretch the membrane. That's all. The roll comes in loose form, and once you stretch the membrane, it's called a stretched membrane theory. The stretched membrane theory. So stretched membrane theory allows you to stretch the membrane by just physically putting two screwdrivers at two diagonals and another two screwdrivers at the other two diagonals, and it is stretched. Why it was not being used in precast was it is slightly difficult to do that, but ma'am has also done that also. So that theory also gets reinforced that you can use chicken mesh also in precast. So absolutely not a problem at all. I'm very happy that why chicken mesh is used, and the diamond shape of the chicken mesh and how it takes the loads is just by simple resolution of forces. There is a global load reduction factor also in while using the chicken meshes. So chicken meshes are simply you can use them in precast, I would say, where generally it is not used in precast because it is easier to use a weld mesh and you did not tighten it. So I'm very happy that she has proved that chicken meshes can be used, which we are all the time saying that you can use it. And I'll come to the other points later.
Okay. Over to Dr. Ashok Jain, sir. These are your comments on the same point.
How do you differentiate between RCC hollow slab and ferrocement hollow slab?
Sir, I didn't compare with the RCC hollow slab, sir. I actually compared it with the RCC solid slab. It is possible to make. It is possible to make, sir. But you see the comparison. A hollow ferrocement slab shows the better behavior when compared to a solid slab, right?
Solid slab is something entirely different.
Solid slab is actually it has got
something entirely different. We are not discussing solid slab. I am just asking the same geometry. If I do it in RCC,
we can very well make some.
Milind, would you like to comment?
Apart from load carrying capacity, there are other features which we have to observe. In case of RCC slab, there will definitely be spalling of concrete, right? When it is subjected to a deflection of, say, even 5 mm deflection, that will be heavy spalling of concrete. But in case of ferrocement slab, all my slabs underwent a deflection of 15 centimeter, and I have never observed any spalling of mortar. I have tested almost 40 slabs totally. Okay, none of the slabs showed spalling of mortar.
1 minute. You are talking about 15 centimeter deflection.
Yes.
And your total thickness of slab is 113.5 centimeter.
Yes, sir.
So your deflection is more than the thickness of the slab.
Yes, sir. It will undergo deflection, large deflection.
I mean, deflection more than its own thickness.
Yes, sir. And the slab will bounce like a rubber ball once the load is removed.
I rest my case.
I will. Can I come in, sir?
Yes, sir.
Please.
I've experimentally found all this, sir. I've experimentally found, and it was.
I agree. I'm not saying that you are not right. What I'm saying is.
So I am very confident what I have done because I have observed everything. Okay. I have determined all the factors. I have observed each and every behavior of the slab, and once the load was removed, also the slab bounced like a rubber ball. Okay, and it did not show any spalling of mortar. That was a very good thing which I observed in case of ferrocement slabs.
You were saying something, Milind?
Yeah, my point was that if she would have cast a precast RCC hollow slab and a precast ferrocement hollow slab which is already cast, and she has done the experimentation, the first differentiation would have come only at the first crack only. And the first crack itself, the stress strain curve is linear up to the first crack, both in we had discussed this both in concrete as well as ferrocement. But in ferrocement, the straight line curve is much longer. That is, from O to A is a very longer distance. So in ferrocement, the first crack would have occurred at a much higher load, or rather putting it inversely, if she were to cast a precast RCC slab, the first crack would have occurred at a lower load, and subsequently the cracking patterns would have been completely different in RCC as compared to ferrocement. In concrete, the cracking patterns would be, the number of cracks would be there, the size of the cracks would also increase, and the number of cracks would also increase. But in ferrocement, the number of cracks would increase, but the crack width would remain same.
Yes.
So you would have a number of cracks, but still it is serviceable. And what was interesting was, of course, I am very surprised because of the 22% or even say 20% strength higher using fibers is actually a revealing thing, because it makes a huge difference if you are adding only fiber, which is very cheap now. Of course, Recrons, I will not advise Recron for a simple reason that it is polyethylene fiber and we need polypropylene fiber. And polyethylene has a very bad quality in terms of concrete. At pH 10 to 11, 10 to 12, it dissolves in concrete. So after 1 or 2 years, the polyethylene Recron fiber generally loses its ability to.
Recron is polyester, sir. It is alkali resistant polyester fiber.
Yeah, but it is polyethylene. Polyester,
No,
polyethylene.
polyethylene is different, sir. I worked with polyethylene fibers also.
Yeah.
This is Recron 3S is polyester. It is alkali resistant polyester fiber. That was the thing which I used.
Yeah. So basically, why they are using polyester is it is a byproduct for them. It is, they make polyester yarn. So because of that yarn, there's a byproduct for them. Similarly for Garwaris also make that, but that is beside the point. My point is that with 20% higher flexural strength, it is a great revelation. And what you showed on the backside of the underside of the slab, precast slab, that is the soffit of the cracking pattern, that subscribes to our thinking, our philosophy of a large number of cracks, but the crack width is smaller.
Crack width.
Yeah, the crack width is smaller, and I think it is confirming to a lot to what we are theoretically trying to explain the behavior of ferrocement. It's a very good experiment in that way. Only if there was one more RCC ferrocement slab, we would have got a complete picture like Ram or Sham, where clearly it is defined that what is Ram and what is Sham, But
because you are comparing a hollow slab with a solid slab. So
yes. The comparison was not apple to apple, unfortunately. But still, it has standalone observations in ferrocement. They are very good, and they corroborate with what we have been speaking. First crack to then the number of cracks, and the yielding of the steel wires. That's a major event which you are showing at the point E. So yielding of steel wires occurs. All the motor gets cracked. Wonderful work on that. Wonderful work.
Thank you, sir. Thank you, sir.
Yes. Thank you, Milind. You have highlighted good features of our presentation. Over to Mr. Owen Waldschlagel. Your comment?
Hi, good evening. Hi, Dr. Shoba. I appreciate your work and your focus. It's helping me understand ferrocement much better. And hopefully I can apply some of your calculations to the work I do someday. Anyway, I appreciate your work very well.
Thank you, sir. Thank you, sir.
Okay. Thank you, Owen. Sadeque, sir, you want to?
Yes, sir. Actually, really, it's a very good work and very good presentation. Actually, I was trying similar to your work. So I have tested in the laboratory. It's a small what we call in our country we use some micropile, 5" by 5" sub pile for small palisading work. Yeah. So I have tested two type of members. Some members, some ferrocement. This is hollow 5" by 5" and RCC member. So actually, I did not go for huge number of sample, but what I have found, the ferrocement member took 1.5 times shows 1.5 times more moment capacity, and the deflection is 3 times more deflection than the concrete member. So, but that means it's much more ductile if we use these ferrocement elements.
Yes.
But I have tried by using these polyfibers, but actually there was I was facing the problem of mixing these polyfibers, because when I tried to mix this polyfiber uniformly distributed, but I could not make that. It becomes lump in some places. So I could not get very good result. It's a very a low difference. When I use poly mesh with the ferrocement, then maybe 3 to 5% more actually strength it shows, more flexile strength it shows. But I could not get actually this 15 to 20% of this. That might be because I could not actually mix this polyfiber. It's very difficult to mix uniformly. When it gets water, then it becomes a lump. That's actually I face this problem. So I think it's a very good word, and I do agree with all of your findings. Yeah. So, and now you can just give me a tips, the method of mixing of polyfiber with the mortar.
Thank you, sir. Thank you. Actually, we had a very great difficulty while mixing. Initially, we had very great difficulty. We tried dry mixing and all, and the same lumps were formed. And finally, we found out a very good. We got a very good idea. We mixed with the water that is to be used for the cement mortar, and we poured the water in the mixing drum. We got a very uniform mix.
That is correct.
With the water, yeah.
Yeah. You add it to the mixing water, and then they use that water for the concrete.
Yeah,
of course,
we poured it in
otherwise,
the mixing drum.
Otherwise, now
similar to the way we mix some admixture, yeah.
Yeah.
Correct.
Yes.
Correct.
Yes.
Okay.
They got a very uniform mix.
Okay.
But now it was done in 2007 and 2010. Now at 2021, we have got glass fibers, we have got nylon fibers, we have got steel fibers, we have got n number of fibers available, which remove this anomaly of bulking of fibers. What Sadeque sir was saying was, when you add water and the fiber, it bulks. And bulking means they get to one side only instead of being a three-dimensional reinforcement.
Yes,
what it is intended to be. So it no longer works as a three-dimensional reinforcement, but it works as bulked up and doesn't give the performance. So that was also good. And another point that she was saying was the what do you call the deflection was like a ball bouncing. Actually, this indicates the ductility. So it is slightly confusing because people might say if the beam is going to or slab is going to bounce like a ball up and down, then how do we walk on it? But the point is that was an ultimate load.
Ultimate load.
That was an ultimate load.
Yes, sir. An ultimate load.
And most important, what happens is in seismic condition, we don't design earthquake proof structures. We design earthquake seismic resistant structures. So the most important is that you have got enough ductility before failure to get out of the building.
Yes.
The serviceability criteria is different from failure. Failure is when the beam is deflecting, coming up again. It is not going down completely. It's not crushing or crashing down. Yes. So that is the time you can bounce back and come out of the building.
It underwent large deflection. Actually, that deflection and that bouncing indicates that still that elasticity nature is maintained in the slab. That's what I
yeah.
Okay, one thing is actually what I was doing a similar job, not as a slab element, but for earth retaining member. So for earth retaining structure, if you can allow the deflection, then the total earth pressure become lower and lower, because when there is no deflection, then earth pressure is at rest condition. And when you allow some deflection, as Ferrocement shows, if you allow deflection against the earth pressure, then earth pressure becoming the active earth pressure, which is about 1/3 of the you see rest pressure. So this ferrocement element, I have got a tremendous benefit using in the earth retaining structure. Just it's a small structure. Just you see in the water body, just in the bank of the water body to sustain the earth, especially in the fish culture. So this works very nicely. These Ferrocement members, yeah.
Yes.
Thank you, sir. Thanks for the information, sir. Thank you, sir.
Yes, thank you. And very well said, Mr. Milindji. You have highlighted the proper uses of different fibers, and as well as we can make the utilization of this kind of property, that ductility or the flexibility of the ferrocement. So both points have been highlighted. I'm seeing Mr. Jain Murudkar for a long time. He is he has the one who has industrialized the ferrocement activities. So let us ask him, Mr. Murudkar, are you there? Hello, can you hear me? Murudkar ji.
Yes.
This question is to you about your experiences in the use of fibers in ferrocement. Are you using
Very nice.
all your precast elements? Please, your comments on 2 minutes.
We are using fiber only for the crack avoid cracks.
Okay.
For other type steels are used only.
But must have been increasing the workability or...
Yeah, definitely.
Okay.
Nowadays the fibers are coming specifically for crack control and specifically for increase in tensile strength. You have polypropylene fibers under the name of crack control to actually control the cracks. The fiber length is different. Length is different, and some fibers are only used for increasing the flexural strength. So they are also for increasing the strength fiber. So we have gone through that much level. Unfortunately, there is again no code in India, but the ACI code is there, which is for polypropylene fibers, which is very extensive and very exhaustive.
Yes.
Thank you, sir.
Okay, thank you, Murudkar ji. We have another participant, Mr. Nandakumar ji, Jadhav. You want to say something? We are not getting your voice. Jadhav?
Actually, the main idea of using fiber was to prevent crack propagation, sir. But we observed increase in strength also. And once the crack is formed, the propagation of crack is very minimal in case of fiber reinforced slabs.
Actually, I have taken the benefit of Ferrocement in another way, because if we go for reinforced concrete, then we have to follow the code and we have to maintain minimum clear cover. So the effective depth becomes lesser, yeah. But for Ferrocement, you can keep a small clear cover, because you see mesh, wire mesh, it does not require much clear cover from the surface. So you can get the benefit of this effective depth of the that is also another advantage for Ferrocement.
Yes, that is very important. That is most important, because what happens, you are putting surface reinforcement, and that surface reinforcement, the closer to the surface, it is a bigger crack arrestor, what they call, and that is correlated to specific surface. The more the specific surface, the more the surface reinforcement, the lesser the cracks and more crack arrested.
Okay. So I think the time is short. We will be now nearing the conclusion. So finally, I thank Dr. Shoba Rajkumar for the excellent presentation.
Nandakumar sir is asking a question, I think, sir.
Yeah.
Sir, Mr. Jadhav, are you listening?
Sir, yeah. Sir, give me I am asking 3 points. One point is Shoba madam has made a hollow slab, but I think Jain sir, Murudkar sir have already precasting hollow slab with the pipes. He will explain, I think that's better than me. Second point is, Shoba madam and Milind sir, which fiber should be used for to avoid the cracking and the given strength to slab? Actually, I am using a fiber, but I don't know which type of fiber I am using, because where I am purchasing, they also don't have technical details of that. They are only telling that we are giving the fiber to avoid the cracks. So, Milind sir point I got now to what type of fiber should be used for strength and avoid the crack.
First choice would be glass fiber. It is inert. Dosage is also very low, and dispersion of the glass fiber is much better than polyethylene, polypropylene fiber. Second is a 3 mm or 6 mm long strand polypropylene fiber, which is also available. But glass fiber is easily available. And if you increase the dose from 85 grams to 170 grams per bag, which is not much, it gives fantastic results.
So I work with 12 mm. I work with 12 mm length polyester fibers.
For concrete. In those days, it was not available. 12 mm only was available. Now you have 6 mm and 3 mm also. 6 mm is used for plaster, and 3 mm is used for ferrocement. You have to order for 3 mm.
Yeah. Okay. Thank you.
Thank you very much. So, thanks to all the participants too. They have made this talk live. We have discussed the different parameters and the different behaviors of the ferrocement elements, right from their hollow components, solid components, then with fibers, without fibers, with chicken meshes, without chicken meshes, the ductile properties, the deflection criteria, all these different issues which are needed for the design purpose to get the proper element custom.